Hi, Science 10s. This is lesson CB5, Predicting Products of Chemical Reactions. Again, as I mentioned in CB4, you need to be very on the last couple of lessons and make sure you know what you're doing. Even stuff from Chem A needs to be very clear. So please reach out if you need some help with naming compounds, if you need help with balancing equations, whatever you need, I'm around. So I started to touch on a couple of these in CB4. If you haven't watched that, make sure you go back and do that. But this is trying to figure out what the products of a chemical reaction will be if you're not given your full equation in words. So as it says here, when you're predicting the products of chemical reactions, you must follow the following steps. So write the formulas for the reactants with their states. CB6 is a lot of state stuff. So we're not going to worry too much about these two items right now, but it does become very important. So don't think that because I'm not doing it right now, you don't have to do it. We will just talk about states next time. So write the formulas for the reactants, classify the reaction types. So either a formation reaction, a decomposition reaction, a single replacement reaction, a double replacement reaction, or a hydrocarbon combustion reaction. So predict the products based on the reaction type. So we'll talk about how you kind of do that. And in the end, balance the equation. So again, if you can't write a chemical formula, you can't do this. If you don't know the 5 reaction types, you can't do this. If you don't know how to balance an equation, you can't do this. It'll be very, very difficult is what I'm trying to say. So make sure you have those kind of first introductory skills ready to go. So our first step again, or our second step, I guess, is trying to figure out the reaction type. So as it says here, if the reaction, if you figure out it's a formation reaction. So again, in CB4, we used our general form. A formation reaction is A plus B produces AB. So taking things in their elemental form and becoming a compound. So the reactants, again, that's what goes in, are just basic elements. The product is a compound made up of these elements. And so, oh, sorry, I guess that has it all there. So if you have two things that are just elements, if you're given sodium reacts with chloride to form something, we know that we have two simple things. So it needs to produce something more complex. So it needs to be a formation reaction because it's not like I could decompose sodium into something simpler. It's not like I could decompose chlorine. It's not like this is a single replacement reaction because again, neither of these are in a compound right now. Chlorine's diatomic, but it's still an element in its elemental form. Sodium's an element as well. So we know this needs to be a formation reaction because it's two simple things, but now we need to think about what product it's going to be. So keep in mind, don't start writing what I'm writing. You don't just write NaCl2 because there's an Na and a Cl2. This is not a compound. That's not actually a thing. So we need to think about back to ionic compounds, our binary ionic. I don't remember what lesson that would be now, but we know in an ionic compound, looking at the charges or the ions that each of these will form in our periodic table, sodium forms a 1 plus, chlorine ion is a 1 minus. So what that's actually going to produce, we know we want our charges to balance out to make an overall neutral compound. So that's going to produce NaCl. Sorry, I can't erase with this right now, so I just gotta do that. So we know that, again, looking at what ions they'll form, so a positive ion, a negative ion, both with 1, positive 1, negative 1. So we know a 1-to-1 ratio will balance out to produce a neutral compound. So that's sodium chloride. So now thinking about balancing the reaction, sorry, I'm kind of out of room right now, Na plus Cl2 produces NaCl. So if we did our little in and out table, or our reactants products, if you're more official than me, 1, 1, 2, 1. So again, we have 2 chlorines going in, only 1 coming out, so I'm going to put a 2 here. Which changes this, but it also changes this. So now I need to put a 2 here. to change this. So what's going in is coming out. What's going in is coming out. And you'd want to recheck back with your original equation. Remember, if there's no number there, that represents a 1. So that's our balanced chemical reaction. I see right now in my key, there's a mistake. There we go. So that's for formations. You need to figure out what the compound will be and then balance it after. So if the reaction is a decomposition, so if you have just one compound as your reactant, so we have lead bromide, is that lead 4? Does lead only form, oh, now you get to listen. Yeah, so lead is a multivalent, so it can form lead 2 or lead 4. So we know that this needs to be lead 4 because, again, bromine forms a 1 minus. So if we had 4 of those, we would have to have, since there's only one lead, 4 plus 4. So that's lead 4 bromide. So it says if it's a decomposition reaction, so we just have one complex thing, we know we can't have it exchanging something, we know we're not producing more compounds out of this. Your reactant is only one thing. So the products of this will be the basic elements of the compound. So we know we're going to form lead, and we know we're going to form bromine. The thing where you'll get stuck here is bromine is found diatomically. It's one of those ones up on your periodic table just above nickel and copper. Those are your polyatomic elements. So bromine is found as Br2 when it's on its own. It's not always Br2 in a compound. You see here it's Br4, but when it's on its own in its elemental form, it's going to be found as Br2. So balancing, I'm not going to make my chart. You need to go back to CB3 if you're not sure how to balance, but it'll balance with a 1:1:2 ratio. So on to the next one. If it's a single replacement reaction, so the way that you can identify that it's a single replacement reaction is one reactant will be an element, the other a compound. So we see here an element and a compound, an element and a compound. So we know that that's going to be that single replacement reaction. So the products will form according to the pattern of single replacement reactions. So that's what that's saying is an anion will switch with an anion. Or a cation will switch with the cation. So for this first one, we have copper and we have gold chlorate. I was right on the first one. So that's gold 3 chlorate because gold, again, can either be gold 3 plus or gold 1 plus. Since chlorate, I'm going to write this all out. I'm talking and not writing, so it's hard to understand. So we know we have copper. So since chlorate forms a 1 minus, we know that this gold needs to be 3 plus. So thinking about what type of ion copper will form in solution. So copper, this is a little bit of a problem. So copper can either form copper 2 plus or copper 1 plus. This is one of the cases, actually, where we're not given which copper it is, and we can't tell just by looking at this. It doesn't tell us. So back when we talked about multivalent things, I said if you're not given enough information, you always assume the top one. So looking at copper, it's atomic number 29. Copper forms a 2 plus or a 1 plus. The top one is the more common one. So we're going to assume that copper is going to form this 2 positive charge because that's the more common one. So we need to think about what's going to switch with what. So we know chlorate is going to stay as this nice big polyatomic. So don't start plucking like oxygen out of it or something like that. We're going to keep our polyatomic together. So now we need to figure out who's going to be together. So we have a positive and a negative and something that's a positive. So as it says here, a cation will switch with a cation. So we know that in my bad examples, this was the one that I called the mistress. So copper, Cu, is our mistress, and it's going to switch places with gold. So it's going to displace the gold. So we know gold is going to be on its own after, and copper is going to be in the compound. So now what we'll have, again, we have ClO3 with one negative, Cu2 plus. So I know I need 2 of those chlorates. So my new compound will be Cu ClO3, and I needed 2 of them. So we have copper plus gold 3 chlorate produces gold and copper 2 chlorate. So again, on a question like this, if you pick the wrong one, I'm probably not going to be too stinky about it. I try to always make it so that you have enough information. But this copper, you should have chose the more common one, which is the one on top in the periodic table. So that gave us our copper 2 chlorate, and that balanced out like that. I don't think our equation is balanced right now. So again, I'm not going to make the whole chart or anything. If you are struggling with that, you need to go back to practice. So thinking about this, I need a 2 here, a 2 here, a 3 here, and a 3 here. So 3 copper in, 3 copper out, 2 gold in, 2 gold out. 2 times 3 is 6 chlorate in, 3 times 2 is 6 chlorate out. So that balances with 3, 2, 2, 3 for the coefficients. Oh, there's one more there for single replacement. So we have chlorine and potassium iodide. So again, chlorine you see found as Cl2, potassium iodide. So thinking about what they form. So chlorine wants to form a 1 minus charge. Potassium forms a 1 plus, and iodine forms a 1 minus. So we have a positive and a negative, and then we have something that will form a negative. So like it's set up top here, a anion will switch with an anion. So we know that chlorine is going to displace something that has the same charge as it. So it's going to end up where iodine was, and iodine is going to be on its own after. So we're going to have KCl, so potassium chloride. Again, it's a 1-to-1 balancing because 1 positive, 1 negative. And iodine. Iodine is one of the things that's found diatomically, so don't just write I here, you need to write I too. For balancing, we know we're going to have a 2 here and a 2 here. So there is a 1 here and a 1 here. So 1 times 2 is 2 chlorine in, 2 times 1 is 2 chlorine out, 2 times 1 is 2 potassium out, 2 iodine in, 2 iodine out. So this is kind of our final equation there. So that's how you predict the product. So the big thing is you're going to have the same charges replace one another. Really important to watching for these things that are found diatomically or polyatomically. It's super important with these ones. So double replacement reaction. If it is a double replacement, I don't know if you guys have blanks here. My notes have blanks, but maybe yours don't. So if your reaction is a double replacement, both reactions will be compounds and products will follow the pattern of double replacement reaction. So again, a cation will replace cation, an anion will replace an anion. You want to have in the end your compounds have a positive and a negative charge. So this first one is nickel nitrate. Nickel is polyatomic, so we actually need to figure out which nickel it is. So nitrate forms a 1 minus. If we have 3 nitrates, we know that this needs to be nickel 3 plus to balance out the 3 negative charges that are coming from the nitrate. Sodium sulfate. Sodium is only ever found as a 1 positive. Oh, sorry, that's not sodium sulfate. That's sodium sulfite, ITE. So Na with the 1 plus, sulfite is SO3 2 minus. So again, this is just representing each of these compounds, what they actually look like. So now we need to figure out who's going to end up with who. So we have a positive and a negative and a positive and a negative. So what we want is, in the end, this positive, so nickel, to end up with the sulfite, and sodium to end up with nitrate. But we're not going to have like these two come together with these three. We've got to think about what it's going to be. So nickel, so we have nickel, and we know that it's nickel 3 plus and sulfate 2 minus. So now we need to figure out what our actual compound will be here. So we know that we'll need to have, I see what I did, SO3 2 minus. So what we see is we have 3 SO3 2 minuses to give us an overall negative charge of 6 minus. We have 2 Ni3 pluses to give us an overall charge of 6 plus. So the way that I write this is Ni2, since I have 2 nickels, and I need to put brackets around a polyatomic, SO3. I needed 3 of those. So Ni2, SO3, 3 of those. And now thinking about our other compound, so again, we want a positive with a negative. So we have sodium, and we have nitrate. That'll balance nicely with a 1-to-1 because again, 1 positive, 1 negative. So balancing this in the end, again, this is a complex balancing one. You'll probably want to consider your polyatomics as one thing. So keep your nitrate together, keep your sulfite together. So when you balance it, I'm just going to write it out below because I definitely don't have room there. So it will balance with 2 NiNO3 3 plus 3 NaSO3 produces 1 Ni3 and 6 NaNO3. So hopefully you balance that out, or we're thinking about it. Double check that the balancing is correct. I found my mistake right away because I was trying to balance it and I saw that that didn't work, but I just forgot to transfer that too. So that's your double replacement reaction. So again, it needs to follow that pattern of double replacement reactions where your positive from your first compound needs to end up with your negative from your second compound and vice versa. If the reaction is a hydrocarbon combustion, one reaction, so again, we're just talking about hydrocarbon combustions here. One reactant will always be a hydrocarbon, so it'll have C something, H some other number. So C1H4 is methane, C2H6 is ethane, and it goes on. The other product will always be oxygen. Sorry, the other reactant will always be oxygen. One product will always be carbon dioxide. The other will always be water. So these ones actually they're a pain to balance, but they're easy to figure out what your different products will be, because it's just going to be carbon dioxide plus water. And so you would have to balance that out. Again, I think we balanced this one last day. So this balances with a 2 here, and a 2 here, and a 1 here, and a 1 here. Again, they're a little bit of a process to balance. So when you're balancing them, balance everything else out. So if you had sulfur or phosphorus or something, usually there's not anything else. So you'll just go on to C, H, and O. So you balance carbon first, hydrogen next. You always want to be balancing oxygen last. So that is the rest of predicting products. Now you have a pretty big beefy worksheet on kind of CB4 and CB5. So you need to identify reaction types and then also predict the products of it. So take your time on that. There might also be balancing on it. Let me just open it up quick and have a peek. Just if I want to give you any tips and tricks. Did I click that? Oh my God. It's not being a friend right now, so I actually can't open it, but there might be balancing as well. I assume there actually is. So think about your 5 reaction types, think about those rules for predicting products, and yeah, you got this. Let's see if it's open up down here. No, my computer's frozen. Hopefully this works. Okay, bye guys. No.